Close your eyes for a moment, picture a wall, see its texture, its strength, its sheer presence. It is a barrier, a boundary, something solid and real, defining the space around it. Now imagine this wall is the largest thing you could possibly conceive of, a structure so vast it dwarfs entire galaxies, stretching across the cosmos for billions of light years. You would expect it to be made of something monumental, countless stars, rivers of glowing gas, perhaps even the enigmatic pull of dark matter. But what if the greatest wall in the universe isn't made of anything at all? What if it's the opposite? An absence, a void, a colossal shadow cast across the dawn of time itself. In our journey tonight, we are not going to explore a structure. We are going to explore a breathtaking emptiness that redefines what it means to be big. Prepare to relax as we drift into the quiet and uncover the truth about the Great Wall in space that isn't a wall, but a shadow. Before we can understand the shadow, we must first understand the light and the tapestry upon which it is projected. For a long time, we imagined the universe as a random scattering of celestial objects, like salt spilled across a dark table. But as our telescopes grew more powerful, a new, magnificent picture began to emerge. The universe, it turns out, is not random at all. It has an architecture. On the grandest of scales, galaxies are not isolated islands. They are drawn together by gravity into a luminous, interconnected structure known as the cosmic web. Imagine a delicate, three-dimensional spider's web spun across the entirety of existence. The long, brilliant threads of this web are called filaments, and they are rivers of galaxies flowing through space for hundreds of millions of light years. Where these filaments cross, they form dense, bright knots. These are the superclusters, sprawling cities of thousands of galaxies, bound together in a gravitational embrace. This is where we live, in a tendril of this cosmic web. But a web is defined as much by its threads as by the spaces between them. And in between the filaments and superclusters lie the great cosmic voids. These are vast, dark, and profoundly empty regions where galaxies are few and far between. It is in the interplay between these structures and these voids, between the something and the nothing, that the story of our Great Wall truly begins. Our story begins with a simple yet profound question. Where is everything? To map the universe is to map its light. In the late 1970s, astronomers at the Harvard-Smithsonian Center for Astrophysics, led by figures like Margaret Geller and John Hutra, began a project that would change our cosmic address forever. They weren't just taking pictures of galaxies, they were measuring their redshift. Imagine the sound of a siren changing pitch as it moves past you. Light does the same thing. As a galaxy rushes away from us in our expanding universe, its light is stretched, shifting towards the red end of the spectrum. The greater the redshift, the farther away the galaxy. By painstakingly measuring the redshift of thousands of galaxies one by one, they were creating not a flat map, but a three-dimensional model of the universe. They were plotting the where and the when. As the data points accumulated, a strange shape began to appear. It was a crude, stick-figure-like pattern, with galaxies clustered along strange, thin surfaces surrounding vast, seemingly empty bubbles. It was the first real glimpse of the cosmic web's texture. This wasn't a random scattershot of points. It was a structure with rules and form. It was as if we had spent our entire existence living in one room of a house and had finally opened the door to see the intricate design of the entire building. The voids were real, the filaments were real, and as they pushed their survey deeper into space, they were about to stumble upon something that the existing models of the universe said shouldn't be there. They were about to find the first Great Wall. Illustration idea, an animation showing the concept of redshift with a light wave stretching. Then a visualization of the CFA2 redshift survey data, points slowly populating a 3D space, gradually revealing the famous stickman figure and the surrounding voids. So, what exactly was this first Great Wall? Let's transition from the abstract to the tangible. or as tangible as a cosmic structure can be. Officially named the CFA2 Great Wall, it was discovered in 1989. As the redshift survey continued, the data revealed a staggering sheet of galaxies, a filament of cosmic web so immense it broke the scale of everything previously known. Let's try to grasp its size. It is located approximately 200 million light-years from Earth. Its length is estimated to be over 500 million light-years, its width 300 million light-years, but its thickness is only about 15 million light-years. It's less of a wall and more of a colossal shimmering curtain woven from the light of thousands upon thousands of galaxies, including the great Hercules supercluster. To put that into perspective, our own Milky Way galaxy is about 100,000 light-years across. If our galaxy were the size of a single grain of sand, the CFA2 Great Wall would be a ribbon of sand stretching for over 8 kilometers, or 5 miles. This discovery was a shock. Cosmological models at the time, which described how matter should clump together after the Big Bang, predicted that structures this large shouldn't have had enough time to form. The universe, at 13.8 billion years old, was thought to be too young for gravity to have corralled so much matter into such a coherent, enormous sheet. It was a profound challenge to our understanding, and it was just the beginning. This Great Wall was a real, physical structure, a place you could, in theory, travel along for eons, passing galaxy after galaxy. It cemented the idea of the cosmic web in our minds, but it also set a precedent. We were now on the hunt for even larger structures, the true giants of the cosmos. Little did we know the next giant we'd find wouldn't be made of galaxies at all. Illustration idea, a dramatic fly-through animation along the plane of the CFA2 Great Wall. We see thousands of galaxies of different shapes and sizes drifting past, emphasizing its nature as a thin, yet incredibly long, sheet of matter. Now let's journey to the very edge of time and space. To understand the shadow, we must first see the light it is cast upon. Imagine the entire universe, moments after its creation, was filled with a hot, dense, opaque fog of plasma. Light could not travel freely, it was trapped, bouncing endlessly between charged particles. For 380,000 years, this was the state of reality. But as the universe expanded, it cooled. Eventually, it became cool enough for protons and electrons to combine and form the first neutral atoms. Suddenly, the fog cleared. The light that was trapped was finally set free, and it flooded the universe in every direction at once. That first light is still traveling today, and we can still see it. It is called the cosmic microwave background, or the CMB. It is, quite literally, the afterglow of the Big Bang. When we look at the CMB with our radio telescopes, we are seeing a snapshot of the universe when it was just an infant. It is the oldest and most distant thing we can possibly observe, and it is almost perfectly uniform. The temperature of this ancient light is the same everywhere we look, down to a few parts in 100,000. Those tiny, minuscule fluctuations in temperature, however, are incredibly important. They are the seeds from which all the structures we see today, the galaxies, the clusters, the great walls of matter, eventually grew. So what happens when you find a spot on this baby picture of the universe that is anomalously, strangely cold? You have found a clue. A mystery that might lead you not to a wall of matter, but to a wall of pure emptiness. Illustration idea. An animation showing the early universe as a hot, opaque fog with light particles bouncing around. As it expands and cools, the fog clears and the light shoots outwards in all directions, eventually reaching a satellite representing our modern telescopes. So we have traveled from the solid, reassuring concept of a wall made of galaxies to the profound and unsettling idea of a wall made of nothing. The Great Wall that is the subject of our journey tonight is not a structure you can see, but a presence you can only detect by what it takes away. It is a shadow cast by an immense supervoid that chills the oldest light in the universe before it reaches us. It is a testament to a profound cosmic truth that the universe is defined as much by its emptiness as it is by its substance. The voids are not just gaps, they are a fundamental part of the grand architecture, shaping the cosmos in ways we are only just beginning to comprehend. The story of this shadow wall is a perfect example of science. It begins with a mystery, a strange, cold spot, and leads to an incredible discovery that deepens our appreciation for the beautiful, complex, and often invisible universe we inhabit. Thank you for joining us on this journey through the light and the dark, the filled and the void. What does the existence of such immense, structured emptiness make you feel? Or a sense of perspective, or perhaps a little bit of loneliness? Share your thoughts with us in the quiet space below.